Welcome to the 9.5 video about inverse trig functions. So now the biggest thing about inverse trig is the fact that there are restrictions. Okay, so inverse trig, which is like cosine inverse, sine inverse, tan inverse, also could be known as arc cosine, arc sine, or arc tangent. So they mean the same thing, just kind of different notation. But cosine inverse is a unique number in the interval 0 to pi, which is huge. So if I'm solving any kind of cosine inverse problem, my answer needs to be between 0 and pi. Well, sine inverse is again a unique number, but this is the only interval it can go between, negative pi halves and pi halves. Inverse tangent, same thing, just between negative pi over 2 and pi over 2. Notice you actually cannot include these. These have the parentheses. So little note here, you can't include, otherwise you would be undefined. Which should make sense to us, because if I take tangent of pi over 2, think about tangent pi over 2, that would be sine of pi over 2 over cosine of pi over 2, 1 over 0, undefined. So that's why I can go all the way up to it, but I cannot include it. Now, the question you could be is like, why does this have this new interval? Sine never had a restriction. Well, it does in inverse, because you want it to be 1 to 1. Think about what we did a couple chapters ago. Horizontal line test comes into play. So if I restrict, so part B here, if I restrict the domain of sine to just be between negative pi halves and pi, I am indeed 1 to 1. Okay, so if I restrict it from pi halves, so right here, sorry, negative pi halves to pi halves, then I have a 1 to 1 function, which makes my inverse possible. Okay, so huge fact, x is sine inverse of x is a unique number in the interval negative pi halves to pi halves. So let's do a couple examples and let's see how you do. So sine inverse of 1/2, you're okay, Thor, lay it down, buddy. Sine inverse of 1/2. Well, for me, I'm going to draw my picture like always. Sine is positive, so I'm thinking, okay, first quadrant, second quadrant, kind of going off of what I've done before. This is 1 over 2, this is 1 over 2, so that makes my angle pi over 6. Now, because I'm in the inverse, sine inverse is only between negative pi halves and pi halves, so it only lives in these two quadrants. So I have to remember for myself to just say, hey, that's not possible for inverse sine. So I'm going to write not in restriction. So all I know is that this first quadrant will be the answer. So in the end, my answer, pi over 6. Okay. Now let's try part B. Now part B, kind of the same idea. I'm going to go back to what I've done before and show how it relates. Sine inverse of negative 1/2. Well, sine is negative in the third and fourth quadrant. I know this would be negative 1 over 2, negative 1 over 2. So again, my reference angle would be pi over 6. But I need to realize this is sine inverse. So inverse is only between negative pi halves and pi halves. So this one, just like before, is not in the restriction. So all I care about is this angle. Now we have to be aware, this is going to be negative pi over 6. You cannot write it as 5 pi over 6. You're like, well, wait, why not? Like 5 pi over 6 is here, around here. Well, yes, that's true, but 5 pi over 6 is not in the restriction. 5 pi over 6 is not, underline it, make it specific, not between my negative pi over 2 to pi over 2. Okay, so that's why this is not an answer. The only answer is negative pi over 6. So this will take some time, but again, if you understand where the restrictions are for each trig function, you'll be in good shape. So, moving on a little bit, quick question, are these equal? Now, a lot of people get these notations mixed up, so I want to make sure we clarify that before we move any further. Sine inverse is 0. Okay, well, let me draw my picture. Sine, remember, is only, sine inverse, is only in these two quadrants. So when is sine 0? Well, sine is 0 right here, at 0. Okay, so sine inverse of 0 is 0. Done. Now let's see what this one on the right says. 1 over sine of 0. Well, 1 over sine of 0. What is sine of 0? Think of unit circle. Well, that's 0. 1 divided by 0 is undefined. So these two things are not equal. So are they equal? No. So don't get that notation mixed up. They're completely different things. It kind of just deals with the inverse versus the reciprocal. Okay, let's do some practice. Compute each quantity that is defined. So part A, we're doing sine inverse of sine of pi over 4. Okay, always start inside out. So I'm going to start with drawing sine of pi fourths. I'm going to do first quadrant just because pi fourths is in the first quadrant. This is pi over 4. Well, that is 1 root 2. Oops, if I could write clearly, that would be helpful. Root 2. Okay, so the sine of pi fourths, I'm just going to kind of fill in little by little. Sine of pi fourths is root 2 over 2. I'm just telling what is the sine of that angle. Now I'm going the other way. Well, sine inverse of root 2 over 2, I'm asking what angle gives me root 2 over 2. Well, that's easy. Pi over 4. Okay, so notice what I'm finding. When I just find sine of the angle, I find that ratio. When I'm finding sine inverse, I'm actually finding the angle that gives me that ratio. We'll practice, we'll be good. Part B, we're doing sine to sine inverse of 2. So I'm going to draw my picture. I know sine inverse is only in the first and fourth quadrant. It's positive, so I'm just going to draw it right here. So this is 2 over 1. So I need to find an angle that has a sine of 2. Now something should be jumping out to you. Can your side be bigger than your hypotenuse? No. Right? The hypotenuse needs to be the biggest side. So in this case, you can't solve it. This is done. You can just write undefined. It is not possible. Okay, and I'm going to write a little note. Not possible. Because side can't be bigger than your hypotenuse. Okay, so that's always something you have to consider, and you wouldn't even be able to find an angle here, so you cannot keep going. It kind of makes you stuck in your tracks. You don't know what to do. Okay, last one. we're going to do part C, so it's kind of a little built in. You have sine, and you have sine inverse of -1 over root 5. Okay, I'm going to draw my picture. I know sine is negative, so I'll be either in this quadrant or this quadrant. I do know that I'm sine inverse, so sine inverse is only in these two quadrants. So I can, in a way, say, oh, not going to happen here because that's not where sine inverse is in the restriction. So here we go. This would be a -1. This would be a root 5. Now this is the angle. Now part A, I was able to find that angle. I knew pi force is a set angle. I know root 2 over 2 gives me the angle of pi force. In this case, I don't know that angle, right? I just know it's some angle. I don't know it yet, but I know it's some angle that gives me this sine. So what I'm going to do in this case is say, okay, it's sine of something. I don't know yet. It's this angle, though. I know it's for sure this picture, this angle. Well, what is the sine of that angle? Well, sine of that angle is -1 over root 5. Please rationalize denominator. We're back at it. So really, -root 5 over 5 is the answer. Oops, did I erase it? Okay, so just keep thinking inside out. Be aware of restrictions. Be aware of where the angle can be, and then you'll be good to go. So quick note I want to write. I'm going to write it over here. Just if you're having a little confused with what am I finding, what's happening. So sine of x. This actually gives you the ratio. So I'm going to write your opposite over your hypotenuse, right? Because that's an angle. Well, sine inverse, that gives you the angle. Make sure the angle is between -pi/2 and pi/2 though. Okay, so this should hopefully clear up why we're doing what we're doing. It's kind of the reverse way. Okay, the inverse of each other. Okay, finishing strong. From a trigonomic to an algebraic expression. Let's see what we're working with. So it says if sine of theta is x over 3, so right away before I even know what's going on, I'm going to draw my picture. I'm in the first quadrant, perfect, x over 3. Okay, express the quantity theta minus sine 2 theta as a function of x. Whenever I see a function of x, I realize that I'm going to have x's in my answer. So do your Pythagorean theorem. Make sure you can get this side to be 9 minus x squared, doing your Pythagorean theorem. And now we're simply plugging in like we did at the beginning of the chapter. Okay, so sine, here we go. So we're going to start with this portion right here, sine of 2 theta. So sine of 2 theta, using our formulas from our half sheet or Schoology, is 2 sine theta cosine theta. Well, I know 2 is 2. My sine is x over 3. My cosine is 1 minus x squared over 9. Or I'm okay with you writing it as 9 minus x squared over 9. Okay, it's the same thing, just representing each element in sine 2 theta. Well, doing some algebra, simplify. This is what sine of 2 theta is. So I have done the circled part of the equation. Think back to what we did at the beginning of this chapter. Now let's actually find the whole part of it. Well, it wants us to find theta. Well, theta, I can't just find. I don't know what that measure of that angle is. I don't know it's 30, I don't know that it's 45, say, like, I don't know. So if I don't know what it is, I'm going to rewrite it as sine inverse of x over 3. I know it's the angle that is given by the inverse of x over 3. Okay, so it is a weird concept, but you combine that all together, and this would be your final answer. It looks very weird. Okay, it does. That's okay. Just make sure you're set to go and you understand that it's okay to have these answers. Now, one thing I do want to mention right here, I kind of made this bold. How did I know I can change cosine into square root of 1 minus sine squared theta? That's kind of an identity you can just use. It's going to be shown below, but just more equivalent forms. You can change cosine into many different ways. It's just whatever will help you in your process. Okay, here are some other helpful forms. If you want them, you can put them on your half sheet or on Schoology. They're there to help you, just if you're doing identities and need a little bit more help. Now, this last page is just a reference for you. So every problem we did today dealt with sine, because I just didn't want to confuse you. This is sine between negative pi halves and pi halves. Well, the same thing goes for cosine, but remember, cosine, you have a different interval. You're between 0 and pi. So if I were to do my graph, inverse cosine falls in this restriction. And actually go back quickly and put it here too so we can see. Remember, inverse sine is here to here. Inverse cosine to get that one-to-one function. And then tangent is between negative pi halves to pi halves. But make sure you don't include these. Don't include this or this, because you'll get undefined. Hence those asymptotes. So use this to help you as you're going through tonight's homework. Ask questions if you have it. The biggest thing is understanding that restriction. You cannot go out of the one-to-one area. Please be aware that answers may look weird. It is okay to have answers that look like this right here because you don't know all the elements. Good luck.